Okay, so here's the review. Again, it has some pretty easy things. It also has some things that factoring, a little harder. But let's go ahead and get through it, okay? So, number one is adding, right? Adding polynomials. Y'all remind me, what is the thing we have to do when we add polynomials? Oh, TV's not on. Sorry, guys. What do we do when we add polynomials? The two jobs we have to do. Put it in standard form, right? And combine my like terms. That's what it's all about. See this big plus sign in between? That means I'm not multiplying. I'm just combining like terms. So let's look at this first one. Is 6x cubed plus 4x plus x squared minus 7 in standard form? Let's put it in standard form. What's the biggest one? 6x cubed. What's the next one? Plus x squared. What's the next one? Plus 4x. And the last? Minus 7. Now, yes, ma'am. Here it is. Yeah, I'm going to put it right here because I need to keep going. All right, so remind me, what does plus mean? We're combining like terms, but when we add, that means none of these signs do what? None of them change. So how will this positive 2x cubed come down? As a positive 2x cubed. Where will it go? Why? Exactly. How will this minus x squared come down? Right underneath this positive x squared. And then how will this plus 3 come down? Right underneath this minus 7. You put your like terms on top of each other, stack them, and then you simply combine like terms. What is 6 plus 2? And what's the rule? Your variables stay the same. Very good. And then what about positive 1 minus 8? Negative 7x squared. What's going to happen to that plus 4x? Drops all the way down. And then what's negative 7 plus 3, or 3 minus 7? So minus 4. And there we have it. There's my answer in standard form. Y'all can do that, can't you? Now this one right here, again, notice there is a big minus sign right in between. So let's start with this first one. Is it in standard form? It's not. I kind of wish it would have been a little different. So it's a little confusing what standard form for this one would be, actually. Yeah, I don't even like this question. Hey, let's make a quick change to it. We're going to put an a cubed right here and right here. Everybody do that for me. I assure you, tomorrow there won't be any question. Okay? I'm sorry this one turned out that way. But anyways, we're all good now, right? What's my biggest exponent? What's my biggest term in that first one? That's right, because remember, when it comes to putting them in order, we always go alphabetically. And since A comes before B, we want the biggest A. So negative 5a cubed is first. What's next? So we got our positive 3a squared b squared. And then what's last? The positive 3ab squared. Okay, everybody good? So now, here's the trick to this problem. What's that minus sign do? That's exactly right. So how will positive 2a squared b squared come down? As a what? As a negative. And where will it go? So it'll come down as a negative 2a squared b squared. What will happen to this negative 9a cubed b? What will it do? It'll change to a positive. Where will it go? It'll go right underneath this 5a cubed b. And then what will happen to this positive 7ab squared? And how will it be when it drops down? it'll be a negative 7ab squared. So please remember, you guys, when you are subtracting, all the signs that follow that minus sign have to change. We still stack them the same way. That way, when we're done stacking them, we can simply combine like terms. What is negative 5 plus 9, or 9 minus 5? So this is 4a cubed b. What's positive 3 minus 2?
Wait, why would it be 4? There's 2 negatives.
Wait, this was a plus. Remember? Because look, it was a negative. It turned to a positive. Right? It turned to a positive. All right, what about positive 3 minus 2? Yep, positive a squared b squared, because technically my coefficient is a 1. And then what's positive 3 minus 7? Negative 4, and your variable stays the same, ab squared. And there you have it, y'all. That is how we add and subtract polynomials. Remember, your review is the only thing you will have on your desk besides a calculator and a pencil. So please pay attention. Now, do y'all see a big plus sign right here? Y'all see a big minus sign right there? So we immediately move into doing what? Multiplying. When we think about multiplying polynomials, we think of what word? It starts with a D. Distributive. We've got to distribute. We've got to distribute. So here we go. Let's distribute. What am I starting with first? 2m. Ready? What's 2m times 3m squared? 6m cubed. Remember, m times m squared, you add your exponents, technically that's 1 plus 2, m cubed. What else does 2m need to multiply by? Negative 4m. What's 2m times negative 4m? Negative 8m squared. Very good. M times m. 1 plus 1. Last, what about 2m times 2? Positive 4m. Very good. I've distributed 2m to everything, have I not? So now what am I ready for? Distribute my 5. What's 5 times 3m squared? Where will that go? Right underneath the 8. The negative 8. Right? How about 5 times negative 4m? And where will it go? Very good. And then lastly, 5 times 2. Positive 10. Very good. Now, all we have to do is combine our like terms vertically. What will that 6m cubed do? So 6m cubed. What's 15 minus 8? Or negative 8 plus 15? No. Positive 7. M squared. What about 4 minus 20? Negative 16m. And then what does that plus 10 do? Drops all the way down. And there we have it. Now, I know you guys like to do some math in your head, but it never hurts. In order to make sure you get it right, it never hurts to double check it. Hey, we're almost done with this section, but let me just give you a little idea of how these will be graded. How many terms does answer 1 have? 4. How many terms does answer 2 have? 1, 2, 3. How many terms does answer 3 have? That's how I'll grade it. If you get that term correct. So, for example, this would be worth 1, 2, 3, 4 different parts. So you might get the 8x cubed right, but you might miss the minus 7x squared. You might get the plus 4x and the minus 4 right, so you would only miss the term you miss. Does that make sense? Okay, let's move to number 4. Again, am I just adding or subtracting like terms? No, because look, all of these parentheses are just right next to each other, which means what? You're distributing. But I've got how many different things being multiplied? 3. Can I do 3 things at once? No, I gotta just start with 2. So let's just start with these first 2 and work our way left to right. Y'all good with that? So here we go. What's m times m? M squared. What's m times negative 2m? Negative 2m. What is 5 times m? Positive 5m. And what is 5 times negative 2? Negative 10. Now we still have to multiply by 1 minus m, but before we do that, what do y'all notice? We got some like terms here, don't we? Let's go ahead and combine those before we multiply this last time. What is 5 minus 2? So what we really have here is we have m squared plus 3m minus 10 being distributed to 1 minus m. And we're going to put them in what order? Standard form. All right, ready? Here we go. What's m squared times 1? M squared. What's m squared times negative m? It's negative m cubed. But where will that go? I'm going to put it out front. And I'm going to add a plus there because that was a positive m squared. Does everybody understand? I'm going to go ahead and try to put it in standard form. Now what do I need to distribute? Positive 3m. All right, what's 3m times 1? 3m. We don't have a 3m yet, do we? How about 3m times negative m? 3m times negative m. It's negative 3m squared, right? M times m, 1 plus 1. So negative 3m squared. Is everybody with me on that? All right, what's the last thing I need to distribute? What's negative 10 times 1? I don't have a constant yet, negative 10. What about negative 10 times negative m? Very good. It's a positive because negative times negative, 10m. So look at that, y'all. That's all of my multiplication. So now how do I find my final answer? Huh? How do I find my final answer? Combine my like terms. So won't negative m cubed just drop? What's positive 1 minus 3? Minus 2m squared. What's positive 3 plus 10? Positive 13m. And then what does minus 10 do? And looky there. My answer. Okay? So that is adding, subtracting, and multiplying polynomials. How y'all feel about that? Adding, subtracting, and multiplying polynomials. Now, let's move into factoring. And I know this is the hard part. Have I ever tricked you guys on a quiz or a test? Huh? I have not. How dare you? I've never tried to trick you guys on a quiz or a test. When I give you a quiz review or I give you a test review, the tests are very similar. So this will not be any different. The difference is this time you get to use your review on your test. So I say this because I want you to consider this before I start going over it. It will still help you to study how to factor. It will still help you to study how to factor. But having this review will also be very helpful. So here we go. Number 5. I'm going to just talk you through the process And then we'll go through it from there, what to do. The first thing you should recognize is how many terms are there, y'all? How many terms are there? Two. There's a handful of ways we've learned how to factor binomials. First, we always start with GCF, greatest common factor. Can I pull something out of 9 and 21? Can I pull something out of 9 and 21? I can definitely pull out a 3. Can I pull something out of x cubed and x squared? So I can pull out 3x squared. So that's exactly what I'm going to do. When I say pull out, I mean divide out. What is 9 divided by 3? 3. What is x cubed divided by x squared? X. So that first term, I'm left with 3x. Next, what's positive 21 divided by 3? 7. Positive 7. And what's x squared divided by x squared? It cancels. So when I pull out 3x squared, Damien, I'm left with 3x plus 7. Right? That's factoring. Let's keep going. Number 4. Binomial. Right? Binomial. Can I pull out any like terms? What? I can pull out a 3. Can I pull out a variable like I just did on number 5? Why not? Yeah, I can't pull out something that 147 doesn't have. So all I can pull out is 3. That leaves me with x to the 4th. Right? 3x to the 4th divided by 3. X to the 4th. What about negative 147 divided by 3?
49.
So minus 49. Now, pause. Don't just say, oh, I'm done. Look at this binomial. X to the 4th. 4 is a multiple of 2.
Oh, you can split it up into 2 binomials.
That's right. This is difference of squares. Why? Well, because anything that's a multiple of 2 is a perfect square when it comes to variables. But what about 49? Will something multiply by itself twice to get 49? 7 will. So guys, we said this is the one time a binomial will factor into 2 binomials. And this is how easy this is. What multiplies by itself to get x to the 4th? X squared times x squared. What did y'all just tell me multiply by itself to get 49? 7 and 7. And what can we do with difference of squares? Plus and minus. Now, look right here. Is this difference of squares as well?
No.
Why not?
Because I'm going to
7's not a perfect square, is it? So this is done. We're done. Can't factor this any further. Y'all with me? Okay, number 7. Can I pull out any like terms? Do I have any GCFs for this binomial? Here's what I would do if I were y'all. And I could give you this piece of paper on the test. I have a big stack of them. I would look at the factors of 64 on my paper. See if they go into 343. That's what I would do. So you could try them. Y'all tell me. Remind you how to do what? Divide it. So what I would do is, if you have your, I'll give you guys this. I'll let y'all have that sheet of paper too. It'll be mine. That's been unwritten on. But if you were to look at your factors of 64, what's the first one? Start big. We'll go big to low.
64.
So what I would do, Kalina, is I would take 343 and divide it by 64 and see if it's even. It's not. It's 5.359375. Definitely not. What's the next one?
32.
32. So I go 343 divided by 32. Also not. What's the next factor of 64? 16. So 343 divided by 16. No, not. What's the next factor of 64? 8. So 343 divided by 8? Nope, not.
Oh, it's another one.
4? 343 divided by 4? Not. So there's nothing that goes into 64 that also goes into 343 except for 1. And does pulling out a 1 help me?
No.
Here's the point. This has no GCF. No GCF. So what should kind of come to your mind when you see this? What should stand out to you?
The threes.
The fact that this A and this B are cubed. It's difference, minus sign, of cubes. Y'all remember how to check to see if a number was a perfect cube? Let me show you. Let me show you real quick. On your calculator, if I wanted to check, since I saw that A cubed and B cubed had cubes, and I know that the only way we factored cubes is if they were sum or difference of cubes. Guys, here's what I do. Go to math. Go to math. Y'all see number 4 right here? Cube root of. Pick number 4 and do the cube root of 64. Is it a perfect cube? 4. Then I would do the same thing. Math number 4 and I would check 343. Is it a perfect cube? So this, guys, is difference of cubes. It's the one time that a binomial factors into a binomial times a trinomial. Y'all ready? Here it is. What did we just say multiplied? Calculator told us. What multiplied by itself 3 times to get 64? 4. What multiplied by itself 3 times to get A cubed? A. So 4A. In that first spot. What did we say multiplied by itself 3 times to get 343? 7. What multiplied by itself 3 times to get B cubed? B. So my 2 in my binomials are 4A and 7B. Remind me what I do with those 2 on the ends of my trinomial. Multiply them by themselves. Square them. Square them. Guys, what's 4A times 4A? 16A squared. What's 7B times 7B? 49B squared. So the ends of our trinomial, we square them. Now what do I do in the middle? I multiply them. Guys, what's 4 times 7? 28. What's A times B? AB. So there's my binomial and my trinomial. All done. Except for one thing. My signs. Guys, if the original one was a minus, what does the binomial have to be? Minus. It's got to take on the original sign. It's got to. It's got to take on the original sign. But to offset that, this middle term has to be plus. And what did we say about the last term? Always plus.
Oh.
It's always plus because you squared it. And anytime you square something, it's got to be positive. You with me? And there you go. That's sum and difference of cubes. Y'all feel good about that? All right, let's keep on going then. Number 8. I think this one's a little more obvious. Are you going to go check in your calculator to see if 125 is a perfect cube? Why am I even checking perfect cubes? Tell me that. It is. But why am I even checking perfect cubes? X cubed. It's a multiple of 3. It can't be a square. 3 is not a multiple of 2. So it's only possible sum of cubes. Did y'all see what it was? Cube root of 125 is 5. It absolutely does work. So same thing as the last problem, right? It's the one time a binomial will factor into a binomial times a trinomial. So here we go. What multiplies by itself 3 times to get x cubed? X. What will multiply by itself 3 times to get 125? 5. There's your binomial. Easy as can be. What do we do with those two things? We multiply them by themselves, right? Square them. What's x times x? X squared. What's 5 times 5? 25. There's my end. There's my ends. What do I do with them in the middle, y'all? What is x times 5? And there you have it. Last thing is my sign. If the original was a plus, the binomial has to be a plus. It has to follow suit. Now what offsets that, y'all? My middle term is minus. But what did we say about the last term? Always positive. Because you squared it. Anytime you square something, it's got to be positive. Because if it was negative times negative, it's positive. It's positive times positive, it's positive. It has to be positive. And there you have it. Y'all good with that? So look, guys, we've done GCF only, number 5. We've done difference of squares. We've done difference of cubes. We've done sum of cubes. Now we do 4-term polynomials. What we call factor by grouping. Did anybody else know that besides her? I hope so. Factor by grouping. It's 4 terms. Is there a GCF? No. It's very rare to have a GCF. Remember me saying that? So we group the first 2 and the second 2. Now, guys, what do I do with that first group? I try to determine what the GCF of that first group is. Can I pull anything out of n cubed and positive 2n squared?
Yep.
What? So I pull n squared out of that first group. Now, what's n cubed divided by n squared? N. What's positive 2n squared divided by n squared? Plus 2. N plus 2. Now, when I go to my next group, remember what I said? You always have to start with whatever that sign is. What is that sign right there? It's minus. Okay, now, can I pull something out of 36 and 72? Bigger. Bigger.
9.
Bigger. 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 36. Guys, tomorrow, look at your factors. Look at, right now, look at 36 and 72. The biggest number they have in common, that's your GCF. So we can pull out minus 36. Watch. What's negative 36 divided by negative 36? 1. And n drops down, so 1n. What's negative 72 divided by negative 36? Positive 2. Now look, guys. Was this factorable?
Yep.
Yeah. How do you know?
Because they match up.
That's right. They match up. Look at that. They match up. So my factors are, what did I pull out? So one of my factors is what I pulled out, n squared minus 36. And what is my other factor? N plus 2.
What if we get one that is not factored?
You would say cannot be factored, or you would say no solution, or something like that. But let me give you a secret. It will be able to factor. There's a little secret. The one on the test tomorrow, you'll be able to factor it. Now, don't stop here. Why? What do y'all notice?
Oh, 36 goes equally into 2, so you can break it down.
Yes, this right here is what we call difference
Square?
of squares. Remember, it's the one time a binomial breaks into 2 binomials. Now, can I do anything with n plus 2, y'all? Of course not. That's no difference of squares. So, n squared minus 36, though, Tayshawn, is, right? What multiplies by itself to get n squared? What multiplies by itself to get 36? What's the rule on difference of squares? Now we're done. Now we're done. Now it's been factored completely. Okay? Y'all with me? All right, let's move along. We come across a trinomial. It says solve by factoring. Y'all know how to solve by factoring? You factor, then you set your factors equal to 0. Remember that? All right, look at this. Can I pull anything out of this trinomial right here? Now look, 20 doesn't have an x